Reactions of alkenes. Reactions of alkenes. So I said, alkenes undergo various reactions. Some of the most important reactions of alkenes include number one. Some of the most important reactions of alkenes include number one, addition reactions. Look at the addition reactions of alkenes. Look at some of the addition reactions of alkenes. Let's take a brief note. No, right, please. Brief note, please. Alkenes undergo various addition. Alkenes undergo various addition reactions, most of which converts them to alkenes. Most of which converts them to alkenes and sometimes alkanols. Most of which converts them to alkenes and sometimes alkanols, depending on the compound being added. Depending on the compound being added. Depending on the compound being added, some of the addition reactions of alkenes include you have this one here. Number one, addition of hydrogen. So number one is addition of hydrogen. We've discussed it already before now. So perhaps you can leave it up. So we're discussing already. Check. Okay, hold on. We discussed in the last class, Abby. Remember, we'll look at what the formation of what? Alkenes. Abby? Yeah, so that's it. We said an alkene will combine with hydrogen under what there? What was PT? Platinum. PD? Palladium. Ni? To give you what there? An alkene. We discussed in the last class. So just get that note there. Moving on to number two, addition of halogen. It's called halogenation. So here's your equation of reaction. I have this, an alkene plus halogen X2 to give you this one here. One X will come here, one X will come here, and I'll have this. That's a dihalide. More like saying that an alkene will combine with a halogen to give you a dihalide structure. Let's get an example. So you try this. Let's use an alkene. Let's use spent 2-in combined with let's say chlorine C2 to give you. Can you try to decipher what the answer will be and draw out the structure? So I've given you 2 hints. Pent2-in combines with chlorine. What do you think will be the answer? And name the compound. Please try this, please. Get your work. Let me do mine. Let's see. So the idea will be pent 2 in. Pent 5 carbon. So 1, 2, 3, 4, 5. For a 2, it means that the double bond is a what there? Carbon 2. So if you choose to call it 1, 2 and put double bond here, you are correct. If you choose to say 1, 2 and put double bond here, you are correct. I want to use this one here. It's the same thing. So this is the 1, 2, 3, 4, 5. Pent 2 in 1, 2. Carbon 2 bears the double bond. Complete this. I have this. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Pent 2 in combines with Cl2 chlorine to give you what? Of course, to give you a corresponding. By corresponding, I mean the same number of what there? Carbon. So I'm having 1, 2, 3, 4, 5. My first task will be here. Come here. 1, 2, 3, 4, 5. That's my first task. Number 2, observe that when the double bond breaks there, your halogens will attach under the 2 carbons that were bearing the double bond. In this case, it was carbon 2 and 3. These 2 here were the ones bearing the double bond. In other words, my 2Cl, of course we said 2 halogen, so my 2 chlorine will be attached under this and this one. Why? They were the ones bearing the double bond. So that means for you, if you are choosing here as your 2, your Cl becomes what there? Here and here. So for mine, it will be these 2, that's this one here. Since these 2 were the ones bearing the double bond, my chlorine comes under here, my chlorine comes under here. Of course, it becomes a single bond. So balance up. I'm having this. 1, 2, 3, 4 complete. 1, 2, 3, 4 complete. 1, 2, 3, 4 complete. 1, 2, 3, and 4. 1, 2, 3, and 4. So that becomes the answer there. How do you know this compound here? This is 1, 2, 3. Becomes 2, 3 dichlorophentane. So it's quite simple. Just understand how it works. Right? These 2 will come under the carbon that was bearing the double bond. That's the idea. It's that simple. Take down, please. That's how many now? 2. We're looking at addition reactions of alkenes. We've done 2, this and this. The third one, let's the third one there. The third addition reactions, addition of hydrogen halide. Take down, please. Equation of the reaction is given below. Equation of the reaction is given below. What does this mean? It means that double bond and alkene will react with a hydrogen halide to give you what there? A haloalkane. So this is called haloalkane, or what there? Alkyl halide. Alright, let's get an example. Example. So any alkene at all, example number 1, any alkene at all, let's say 1, 2, 3. Let's mix an alkene. That means one a double bond there. I'm having, okay, you know what? You know what? On your own, no, let's save time. So 1, 2, 3. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So you have this for the alkene plus HX. So plus H. Let's take X as what? What should we use? Let's use X as being iodine. So it becomes Hi, not high, but hydrogen. Hi, what do you call this? Huh? Hydrogen iodine. Hydrogen what there? Iodide. Hydrogen iodide. Bromide, chloride, fluoride, iodide. That's the name. Not iodide though. Like iodide. So look up, please. Look up. Listen. The idea is very simple. See, the idea is simple. For your end product, it will be, look at that place that had double bond. It will break off to single. And then those two carbon atoms that were bearing the double bond, one will take hydrogen, the other takes what there? The iodine, that's all. In other words, my final result will be this 1, 2, 3. So I'm having 1, 2, 3. That's all. Now I'm having this one here. Observe that it was these two that had double bond. So I said this one will break off to a single bond. These two, one of them will carry the H. One of them will carry what there? The iodine. That's all. That's all. Now complete this. 1, 2, 3, 4. 1, 2. Connect these two first. So 1, 2, 3, 4. 1, 2, 3, 4. That's all. How do you call this, please? It's called 1 iodo-propane. 1 iodo-propane or iodo-pro. No. Please. 1 iodo-propane. This is called the propene. I'll tell you why it's propene, not necessarily prop 1 in. Because there's no prop 2 in. So prop 1 in, propene, so I have this. There is something peculiar about this reaction. This is one of the most important reactions. So please add an asterisk to this one too. Take that, please. The reaction above is called Markovnikov's addition. The reaction above is called Markovnikov's addition. Please take note of this. I'm going to note two things. Last class I said what there? Grignard reagent. Now I'm telling you to note Markovnikov. Listen. Someone is asking, listen. See the difference between equation of reaction and then example reaction. In equation of reaction, I left these ones here without putting H. Why? Because they can be continued. So observe that in this one I had 2 carbon. In my example I have what there? 3 carbon. I continued it. That's why I left it this way here. But if you're doing an example like this one, please do not leave it blank. Please. Because if you submit to me like this, you now leave it blank and submit to me. Now just go and find blue pen and put here and continue for you. So please complete it. Yes. Now listen. Why is it called Markovnikov? Please take that, please. Markovnikov's addition. So let me define this. I said it's one of the most important. So let me define it, please. Markovnikov's addition involves the reaction. Markovnikov's addition involves the reaction of an alkene with a hydrogen halide to produce an alkyl halide to produce an alkyl halide in brackets haloalkane. I've said they mean the same thing. I've explained before. Markovnikov's addition is the reaction of an alkene with hydrogen halide to produce an alkyl halide in brackets haloalkane. Please add there, in the absence of a peroxide. In the absence of a peroxide. In the absence of a peroxide. Full stop. When a peroxide is included, when a peroxide is included, the reaction is called anti-Markovnikov's reaction. When a peroxide is included, the reaction is called an anti-Markovnikov's reaction. Anti-A-N-T-I. What you call anti? It's not anti. It's anti. It's not. That's not anti. It's not antichrist. It's anti-Christ. It's anti. So look up. Look up. I am saying this. What you have here is a Markovnikov's addition. For anti-Markovnikov, it is exactly the same thing. The difference is that I'll add what there? A peroxide, H2O2. This one here becomes what there? An anti-Markovnikov. So that's it, please. Difference between Markovnikov and anti-Markovnikov is the presence of what there? A peroxide. The popular peroxide includes this one here, hydrogen peroxide, this one here, sodium peroxide, this one here, barium peroxide. So these are some of the peroxide you can use. That's it. That's it. Let's proceed, please. Next one there, please. The addition of water. This is called hydration. Dehydration of alkenes, results in the formations of alcohols. Dehydration of alkenes results in the formation of alcohols. Results in the formation of alcohols. Let me give you a task. Who put 2 in and your initiative form a reaction for this. Use but2 in as your alkene, add it to water and see if you can get your product here, please. That's your task. Use but2 in, combine with water and see if you can get your product. Let's get it done. But2 in, but 4 carbon, 1, 2, 3, 4. By 2 in, it means double bond is on carbon 2. Count this way, 1, 2, like this. Count this way, 1, 2, same thing. Complete this, I have 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. That's but2 in. Combine this with water, H2O, and hydrogen ion, H plus. What do you get? We said you have a corresponding. So by corresponding, I have 1, 2, 3, 4. I have 1, 2, 3, 4. Observe that in the corresponding, they are singly bonded in quotes or single bonded. That means it has to be a single bonding. The idea will now be this. Right, OHH. That means the two carbons bearing the double bond, one of them will take H, the other OH. So these two were the ones bearing the double bond. One of these will take H, the other OH. Complete the structure. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So if I should name this, it becomes 1, 2. It becomes 2 butanol or butan 2-ol. So butan 2-ol. This is what you get majorly. And I said there's a minor product. What's your minor product? Check very well. How many oxygen? 1, 1. How many hydrogen total? Okay, how many carbon? 1, 2, 3, 4. 4, that's complete. How many hydrogen? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then this one, 11. How many here? 1, 2, 3. Is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 now. Here I'm having, hold on, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Abi? What again there? Plus what there? Plus H. So you see why, hold on, you now see why they didn't add the H there. Of course, H is not really that important. So I'm taking it off. So that's why they didn't put the H there. It left like this. But we informed that the hydrogen ion acts probably as a catalyst here. So I have butan 2-ol. Next up, please. E. Next up, please. E. E. Halohydrin formation. This involves adding an alkene. This involves adding an alkene to a halogen. It involves adding an alkene to a halogen and water. It involves adding a halogen, an alkene, please, to a halogen and water, resulting in the formation of a haloalkanol, resulting in the formation of a haloalkanol and hydrogen halide, resulting in the formation of a haloalkanol and hydrogen halide. So see if you can get out the equation of the reaction on your own. Okay, should I do it? Please try, please. Now listen. Here's how it's done. Please, what's the first thing there? Okay, before then, how many reactants do I have there? 3. What's the first thing there? Observe that alkene, we always use what there? 2. Abi? Yes, when we use 2 carbon, it's also like this. 1, 2. This. It's always like this. Alkene plus what there? Please, your halogen, it's X, Abi? Yes. Is it X or X2? X. It's X2, that's why she missed it out. That's what she missed, because she wrote X, so it's correct. Why? Because halogens are what there? Diatomic. So it cannot be X, it's X2. So it becomes plus X2. Halogens are diatomic. Next up, plus water. There's no way you don't know water now. So plus what there? H2O. To give you what there? When you hear the word halo and alkanol, it means an alkane that has what there? A halogen. Don't forget, we are maintaining the same two, so it becomes something of this nature here. 1, 2. An alkanol has to have an OH. When we now say haloalkanol, that means this must also have what there? A halogen. So come here and put what there? X, not Cl. X. And then this, plus what there? Hydrogen halide. H and what there? X. Very simple. Very simple. Please use hex 3 in. See if you can form a complete compound. Name your major compounds. Use X. Use X as chlorine. Use X as chlorine. Use hex 3 in. See if you can form a complete equation of reaction. Then name your major compounds there. So look up. The stuff is simple. What's the first? Look up. Look up. Hex. How many carbon there? So I'm having 1, 2, 3, 4, 5, 6. They say hex 3 in. To carbon 3, 1, 2, 3, add double bond. That's hex 3 in. Complete the structure. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Hex 3 in. Combines with, we said X should be what there? Chlorine. So because what there? Cl2. Plus what there? Water. That becomes what there? H2O. To give you what? First of all, is a corresponding. So get number of carbon there. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I have this. What next? I've said this over and over and over again. Observe that in your answer is not X and X. Maybe you give me X and X. It's not die. It's X and OH. That means those carbon bearing the double bond, one of them takes X, the other one takes what there? OH. That's it. So which of these two bears there? This and this. So this, the third one here, the third one takes what there? Cl. That's X. The other one takes what there? OH. Very simple something. OH. Now balance up here. I'm having H, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Some of you missed out on the naming. But I don't blame you though, because we've not done alcohols yet. So I don't blame you though. But listen, when it comes to this, when it comes to, see, the idea of taking substituent as priority is only for alkenes. For alkenes, your double bond is the priority. For alkynes, the triple bond is the priority. For alcohols, the OH is your priority. In other words, I will name this in such a way that the OH becomes what there? The smaller number. If I name this left to right, I'm having 1, 2, 3, 4. Carbon 4 bears OH. Name it right to left, I'm having what there? 1, 2, 3. Carbon 3 bears OH. That's the smallest one. So my number becomes 1, 2, 3, 4, 5, 6. So that's the OH. So I'm taking the OH over the chlorine. That's the idea. So name this, what do you have here? Yes. So you are giving me 3 chloro, 4. No, it's 4 chloro. All right, so I'm having 4 chloro, 3 hexanol, or 4 chloro, hexan 3 or. That's not all. I'm still left with what there? Plus HCl. Very simple something there. It's simple. Just use your eyes. That's all.
Alright guys, don't forget that you can get the complete organic chemistry course on my website. Simply visit www.jonahemmanuel.com/courses and then you see the organic chemistry full course. Alright, it gives you access to my detailed lecture on all the homologous series from alkanes, alkenes, alkynes, alcohols, ether, esters, including their nomenclature, their preparation, and all the reactions they undergo. Alright, or you can simply join my organic chemistry channel membership to get access to these video lessons. Alright.